Welcome back into another video. That's about the mapping and functions. It's a continuation of the previous topics, right? What we're doing here, we are discussing issues about the mapping and functions. But now, before we move into today's discussion, I have to emphasize the point here that every time we would like to maybe learn something, as far as maths is concerned, remember to update yourself about what we discussed in the past. So I encourage you to go back before you join us into this video, right? In case you are joining us for the first time, right? And for those maybe we were together, but you have forgotten some stuff, please use the link down here. You revise what we discussed in the previous videos, right? And all other videos in the past has to be revised. Don't just concentrate on only one video. No, maths is wide. You know our syllabus has a lot of topics. So we've discussed a lot of issues and there are a lot of videos in the past year. Just to go by the link and start right away from the beginning. Right, that's the way we should sell. So here, what we have here is the endpoint of the discussion in the mapping and function. And the last section indeed, where we just only need, as previously we did, where we were discussing on issues on how best we can find the values of the range given members of a domain. This time around now it's just like the opposite, where we need just to work out on the values of the what? Of the domain given values of the range. Maybe here and there will be just like maybe 2 or 1 problem that is there just to bring us an issue about just the application light, but rather our main focus is there where we need to work out on the values of range. So our subtitle here talks of the finding range, not range, but now domain given a range. Right. So I have 3 examples here, of which they will help us to at least understand on how best we can take ourselves through until at the end we know how to work out the members of a particular set given the other one. Right, so here we are given a function of x, where we're told that function of x, a function of x is such that f of x is equal to x squared plus x minus 4. Right. So here we are given that f of x is 8, f of x is equal to 8, and they're asking us to find the value of x. So it's more just like 8 corresponds to what value. Right. So first let me explain here what this one is all about, so that when we start solving it should not be lost. What is A as earlier explained? I talked of the presentation of the elements in particular set versus the other elements in the other set. So I pointed out, say, when we have got a set of a domain, right, like this one here, and we have got a set of a range somewhere here, or should be in the position that, say, as I mentioned, if here we have got members represented by a particular variable like x. So it means we have got x1, x2, x3, x4. It means the corresponding values here, whatever you get here, every value that you get there, that one is defined by f of x as such. And it goes for all kind of variables that are used in the particular function. If it is y, then talk of y1, y2, y3. Then whatever you have here, talk of the y, f of y1, f of y2, f of y3. So what we have in the question here is more something like this one that I have just presented here on the board. What is it? The talk of f of x is 8. So what we have here is more like f of x here. I'll substitute for 8. It's more like I've already processed out the value of the range as 8. So what we are lacking here is the value of x. Right. So there's an operation in between here, and this is defined by this function here. That's f of x is equal to x squared plus x minus 4. So it's just like whatever whatever bridges up the x and f of x here, in this case, is the operation. Let me write this one first of all. F of x is the operation defined by this function like f of x equal to x squared plus x minus 4. So it is this one here that assigns a member for this one from this. Right. So what is here? What we are told is just like f of x is 8. So which means here the value after processing the x here, what we have is 8. So it's more like what would be the value of what? X in this case. So you can see that this one is a member of a range. Now we are here going to find the member of what? A domain. So that's why here I've written up there to say find the domain given a range. Right. So what application are we going to have in this case? So that we have to find the value of x in this particular instance. So what you could do here as a student, from what I've just explained here, you can be able to come up with the application of some kind in order to obtain the value of x in this manner. Right, look at this. Sorry, because of space, I might be writing up the expressions now and again. Bear with me that way. F of x is equal to x squared plus x minus 4. That's the function. But here we're told that f of x is 8. So which means here if we're given f of x is equal to 8, as a student, just a matter of considering that this one as just like an equation. What I want is to find the value of x. So you just have to substitute wherever you see this f of x there in that equation, substitute for 8. So like here f of x is that. It means wherever I see f of x in this equation here there's f of x, here I'll substitute for 8. So instead of writing f of x, what I'll do, I'll write 8 and have a situation that looks more something like this. Here I have 8 equal to x squared plus x minus 4. Right. So now what do I do now? In here, it's just a matter of working out the value of x as such. Right. So all knowledge about the equation should now come in my head. Right now, if I've got given a particular type of equation, how do we solve it? Remember, there are several types of equations, and those types of equations are solved differently. And we need to apply the principles attached to them. Right. So you need first of all to describe the type of equation that you have. You cannot just come in and work out, solve up the equation without really getting to know what methods are attached towards it. Like here, you'll be able to appreciate that this type of equation has got a quadratic term, which is x squared. So then you're going to define the entire equation as a quadratic equation. So all operations that are involved in the quadratic equations has to be utilized. Right. So realizing that this quadratic equation, we know for sure that the first stage that you should take in order to handle quadratic equations is by equating the equation to 0 itself. So what I'll do here, without wasting time, I will consider 8 to be transferred to the right hand side and have here a 0 and here x squared plus x minus 4. And this when it comes here, it also be minus 8. Right. So now from there, I'll do the operations directly. The question will guide me that do ABCD. Like for starting point here, I have to at least deal with the like terms. So I have a 0 here equal to x squared plus x. This minus that give us minus 12. So it's like 0 is equal to x squared minus plus x minus 12. So a same way as we write x squared plus x minus 12 is 0. Right. Once the equation is equated to 0 and the like terms have been simplified, what next? You remember that the next stage, by the first video we had in the first topic, I mentioned here that the next step that you consider is factorization of the quadratic expression of that equation. So it means we are going to factorize this one out and find the factors of which. Right. So by grouping method, if we were to look at the x squared plus x minus 12 to find the factors of this one, the factors of which will be x, you look at the factors that are factors of minus 12 in this case, that when you add, they have to give you the coefficient of the middle term. So the coefficient of x here is 1. So what factors do we have for negative 12 that can give us positive 1? So you find that the factors of minus 12 that can give us positive 1 are positive 4 and the minus 3. Right. So you write those factors in the two brackets and write here x and x. So which simply means when you multiply by expanding this and that, you are going to obtain x squared plus x minus 12. Or one way, maybe you are lost here, just go direct as we have been doing. You group the method by beginning first of all, multiplying this one by this one, and you go as such. You're going to obtain the same factors here. Like, so when you factorize x squared plus x minus 12, the solutions at hand that we get are x plus 4 and x minus 3. So it means x plus 4, x minus 3 is equal to 0. Right. Now from there, where do we go? By what we said, if two brackets are multiplied and the expression of which is equated to 0, that is as good as rewriting x plus 4 alone is equal to 0, or also x minus 3 here is equal to 0. Then from there, you work out the value of x by isolating x itself. So it means they are like terms for the 4 and the 0, and here minus 3 and the 0. So you have got x is equal to 4 comes here, and does the operation of the 0, you get a negative 4. Or here, what you have our x give us what? When it comes there, it be a 3. Right. So in this case, we have an expression that is giving us that. Say that in this case, the total of x is equal to a negative 4 or a 3. This is our solution. Right. So that's it for question number 1. Now let us also move into question number 2. Right, we don't have enough space here. So what you should be doing is like once we have finished up the problem, then next you can at least play back the video if you like, maybe to go through and maybe study more in case maybe you've missed a particular explanation. You can be playing back. That's the goodness of a video. Right? It means the exact what was said is going to be said again. Right? You're going to learn more. Right. Now let's go to question number 2. Allow me to lay this one off so that we see what we have in question 2. Given that g of x, that's the function, in g is equal to x squared minus 4x, then that's what? Minus 6. They ask us to solve the equation g of x is equal to x. Right. Now, these are the kind of questions now you should expect in exams. We have known the functions, the mapping and the like. Now we are here. Down. Try to add the three type of questions that we need to expect. So expect questions to come like that. Sometimes not always direct, you know. At least they just need you to. They're just trying to assess you. Do you really have skills? Have knowledge about this topic? Things like that. So the question may come, but not very difficult as such. Just simple application based on what we're discussing. So we are given g of x is equal to x squared minus 4x minus 6. And yet here we are told that g of x is x. What's the question like? We solve the equation. G of x is equal to x. Right. So if we are to follow what we have discussed in the first example, if you not, go back to that example, now and again, replay, then after, set up the knowledge, you'll be able to realize that what we had earlier can somehow be applied in the next problem here. Like a question we need to solve for g of x. So here what means that, like say, wherever there's g of x, understandably, we know that J of x is this. So why don't you just substitute? At that time, we're substituting for 8. So for the J of x, we're going to write this. That is x squared minus 4x minus 6. That's it for this one, J of x. And this one is equal to x. That's the way it will be. Function is this, but we're required to solve the equation J of x is x. So it means wherever there's J of x, we substitute for the value of J of x, which happens to be this. So you can see me removing this one and write this one down here. So as such, we're going to obtain this type of equation. So what do? Identify the type of equation you are having at hand. There's a quadratic term, then deduce that the entire equation is what? Quadratic equation. Right. So the principles of which must be followed. Equate the equation to 0, which means we have got x squared minus 4x. This comes to this side where we will have negative x, then negative 6 is equal to 0. Right. So here we have x squared minus 4x minus x. We get minus 5x. And this gives us what? Minus 6 is equal to 0 as such. Now what we need to do is simply to factorize this one out. We need to factorize this expression. We know don't change the tactics. It remains as it is. Quadratic requires us to do ABCD and we have to take the same styles. So equating to 0, the next, consider the quadratic expression part of the equation and you need to factorize it out. So we're going to factorize this one here. So it'd be like as it was earlier. You can go by grouping this C multiplied by that, factors of which it goes down here. At the very end, what you do, you are going to obtain the factors of this entire expression by two binomials, which will be equal to 0. So it's just as good sometimes just look at the factors of negative 6. If you have got this expression, but here the coefficient is 1, you just have to look for the factors of negative 6, that when you multiply, give you negative 6, but when you add, you have got negative 5. Right, and here you write x, there again x. So factors of negative 6, that can give you negative 5 are negative 6 itself and a 1. Positive 1 and negative 6. This multiplied by this, negative 6, negative 1, negative 6 plus 1, the answer is negative 5. So one factor has to be fixed in the first bracket. You can decide to write negative 1, solely positive 1, or else like negative 6 is no problem. This other one will have negative 6 as such. So as I earlier explained, when you have got two brackets which are multiplying, then that if those brackets are equated to 0, then it's just as good as any one of those brackets should be equated to 0. So one at a time. So therefore here what we have from that stage, we have x plus 1 is 0 or x minus 6 is 0. Aside from there, you are going to find the value of x as equal to negative 1 by arranging like terms together, and here you get the value of x as 6. Right. So these are the values of x in this category. So try to be familiar on how we are doing the operations here. It's just simple. We are all applying the same knowledge about the mappings and the functions. Right. Lastly, let us look at the questions of category 3, where we are given that f of t is equal to t plus 3. They are asking us to complete the diagram. Right. So it means somewhere we have a gap to be filled, and really it's true by what you can see here. You find that in the first set here, we do just have the variables represented by A, B, and C. But in the other set, probably this other set, the arrows are stipulated here. They tell us that these are just like the image members of the first members in the first category of the set. So definitely these are members of the range. These are members of the what? Of the domain. So it's more like we need to wake up the value of the members of the domain given members of the range. Right. So how do we go about this? Just simple. Applications will be based on what we have already discussed. Remember what I said earlier. Each time you have got what? Two categories of sets. Remember that whatever we have here is just like f of something, because it's coming from the operations of a particular relation. So in relation, in this case, we are given is just f of a t equal to t plus 3, right? And this ratio is the one that, in this case, the moment we talk of a t, it means we have got the first set here, which is defined by members represented by t. So it's just like t1, t2, t3. So what you have here is just like f of a t, then f of a t, and here f of what? A t. So this is mapped onto that is mapped to this, that one is mapped in that, understandably. So this is ft1, ft2, ft what? 3, such. That's the starting point of what should be in your head. But now in this case, we have like whatever is there for ft1, the value of which has already been found as 6. So here we have got 6. For this one we have got what? 8. This one we have got what? 9. That's what it means there. But now here, what we have for t is a value which is a, here is b, here is what? Is c. So what we're going to do here, whatever value of a, b, and c that we're going to obtain here, these values are just like the values of t as such. So it's just like a t we get for t1 we get here, that will be the value of a, t2 we get here, it will be the value of b, t3 we get here, it will be the value of what? Value of c. So first, let's try to understand this one here. That's the whatever is here are defined as t as members, and here what we have in the other set, those are f of t's, right? So by the operation we have here, f of t is equal to t plus 3. So what we have here, for us to find the values of t1, which is in this case a, I substitute a, t2, you take the b inside here, t3, which is the c in this case, it means we can still take ourselves into the same operation, this relation here. But here what we have here, whatever we see here, 6, 8, 9, these are defined as f of t's. So which means in this function here, it's more like an equation. F of t is equal to t plus 3. So which means if I'd like to find the value of this gap here, I know for sure this one is a t. So what I'll do here is just a matter of substituting. Wherever I have got f of a t, I'll substitute with a 6. So what I'll have is like where I have f of a t, I'll write here f of a t, in this case has yielded up to be 6. That one should be equal to t plus a 3. So what I obtain, it will be like 6. This comes here, minus 3 is equal to a t. So 6 minus 3, we get a 3, and this is t. Right. F of t, I repeat, in this case, is a 6. So in your function here, wherever you see f of a t, substitute with a 6. Right. So it means in this case, t is 6, is 3. This one is the operation carried out from the first value of the range, which is 6. That maps a. So which means a in this case is 3. Right, that is t1. Now let's go for t2, which is this one here, where its corresponding value for the range is 8. So what we do there is the same as we have done earlier, where we have f of a t. For this one, it will be now 8 equal to t plus 3. So to find t, like terms together, this comes here, you have 8 minus 3 is equal to t, and here you got a 5 is equal to t. So this t is the second t, t2, represented by b. So our b in this case is equal to what? 5. Right? Lastly, let's consider each about the corresponding value to 9, right? In the first set, which is set of a domain. So here f of t is 9. So it means wherever I've got this c, wherever I see f of t in this function, absolute with a 9. So it means f of t here, I write a 9 is equal to t plus 3, right? So what I'll have here, like terms together, it means 9 is going to do operation with a 3. In that case, now it will be negative. And here give us a t. So 9 minus 3, this gives us 6. That one is equal to t. So the value of t in this case is 6. So this t is t3 and represented by variable c. So at c there, we are going to substitute for what? 6, like that. So that's the way it works. So all what we have been working here, these are members of the set of the domain, and what we are given here, these are members of the set of a range. Right. So which means to finalize everything about that diagram match that we have been asked to complete, it means the conclusion of which shall be indicated as follows, right? So you have your arrow diagram represented like this. 3, 5, 6 is the set of the, that's the domain, right? Which has to correspond to the set of the range, which has members like 6, 8, 9. That's what we have obtained. So it's like 3 maps onto 6, 5 maps onto 8, and 6 maps onto 9. By the operation, f of a t is equal to what? That's a t plus 3. That's the relation. So you can even include the description of the set here, a set of the domain, and here set of a range. Right. So that's it about what we need to know on how we can calculate the members of the domain given the list of the members of the range. And this concludes the entire topic, right? So before I leave, let me just give you an exercise that you can just work on. This is the exercise on your own. Try just to work on it so that you can update yourself. What do we have here? We are given, they say for each exercise here, for each of the following functions, find the image of -2, -1, 0, 1, 2, and 4. The first function is this one. F of x is equal to x squared minus 2x plus 1. The second one is g of x is equal to x minus 1 squared. And lastly, we have got a function here, h of x is equal to x minus 2 over x plus 2. Right. So this is a cover-up or concluding exercise that your students should have. Right. So once again, thank you very much for being nice students as such. Right. Hope you have been connected to the mapping and function, and they have understood everything very well. You know what a mapping is, you know what a function is. And the questions attached related to the set of the domain and the range and somewhere applied type of questions, you've been in the position you guys at least work on. Please maximize your revision. Right, always update yourself by the links down here. Go back from the starting point, update yourself, and get connected to all the videos, and then you'll be somebody else. Thank you very much.